Hello, students, getting into 6.3 homework. So 6.3 homework looks like 1 through 10, 12 through 15. So basically I skipped 11 and 16. All right, let's take a look at these and see how they look compared to what we talked about in the first component. So I skipped 11 and 16. Okay, so I skipped 11, which is you multiply by 3. So that's very algebraic. Yep. 16, I just thought the wording of that one was too complex. And how far did I say to go? Up to 23. So is that all of them, or did I skip some at the end too? Yeah, I skipped a few at the end here. Okay. All right. I'm not that these are bad questions, so that's these are not necessarily bad, just a little bit uh, beyond what I thought we needed. So go up to 23. Okay, so let's talk about these. We'll walk through them. All right, 6.3. All right, in the following figure, so this is the rectangular approach. Your goal is to kind of rewrite this as a multiplication problem. What two fractions are being multiplied, and what is the result of the multiplication? Okay, and then for number two, let's see here, you are given fraction multiplication, and you're going to multiply using rectangles. And please use rectangles. Do not get into circles because, again, it's going to be really hard to draw 2/5 with a circle. So if it was 3/5 times, I don't know, 2/3, doesn't matter. I'm mixing questions between between these two just to kind of give another example. But you could draw yourself what do fifths look like. So 1, 2, 3, 4. So here's 5 vertical stripes, right? And then you could do it kind of one-sided and say, okay, well, I'm going to do kind of slants here because I want to get three of those fifths. I want to be shaded. Okay. And then I want to take 2/3 of that amount. So now I switch colors and I say, now I'm going to do thirds. And I'm going to shade 2/3, but I'm going to go the other direction. I'm going to slant so we can kind of see this cross-hatch design. And the idea here would be to say, well, what number of pieces were hit by both? And we could say, well, there's this one, this one, this one, this one, this one, and this one. So 6 pieces out of how many pieces total? And there would be 15 pieces. So your answer would be 6 out of 15. Yes, if you want to simplify that, go right ahead. You could rewrite this as 2/5. But I want to make sure that you can demonstrate where it comes from in a picture. Okay, you're going to be dealing with students. They need to be able to see it visually. Let's see here. Then you get some practice with multiplication. I really try to make sure you have some mixed numbers in here so that you are forced to either multiply them as mixed numbers or forced to think of these as improper fractions. Okay. Now you can do it either way here. For number 4, it says use the distributive property. So for this one, you cannot turn them into improper fractions. I want you to distribute them to show you, yes, you can do it. And sometimes, maybe in part C, maybe it is a little bit easier in part C. Maybe. I'm not so sure. I think the numbers just get too big, but totally up to you. Try it. I want you to try it both ways. Okay, find the multiplicative inverse. Fantastic. Remember, that's the number I multiply to get back to the number 1. So if you start with a negative, you better multiply by a negative so you get back to +1. Here we're solving for x. Sometimes you'll see a division problem. It might be easier to rewrite it as multiplication. If you see a multiplication problem, it might be easier to rewrite it as division. If you see multiplication and division with addition and subtraction, try to get all your variables on one side, combine like terms, and go from there. Let's see here. Find a fraction that if you add the denominator and numerator, place it over. This is a good one. So this is a word problem. So read through it. You're trying to find a fraction, and you're adding denominator to the numerator, and place the sum over the original denominator. The new fraction has 3 times the value of the original fraction. As a big tip, just start with a fraction. The original fraction has to be something like an A over B. Then go through the problem. You'll have a whole bunch of A's and B's in it, and you'll get to use techniques like from question number 6 to get everything onto one side and find a fraction. Question 8, find all of these mentally. Again, when it says divide by 1/2, you can find it mentally using any technique you want. If you're trying to find it mentally, yes, you can invert and multiply, but you could also rewrite this as a common denominator and then divide straight across. So don't forget you have both of these really cool approaches as you're doing it. Question 9 is choose from the best number to approximate. Okay, so now I'm asking you to approximate. Is this answer going to be closer to the number 2, to the number 10, the number 1/2, or the number 180? So again, as you're thinking about this, what numbers are these close to? Try to pick some good compatible numbers, and I think you'll have a good time with those. And lastly, without doing the computations, choose whether this is greater than 2, less than 2. Without doing the actual computation, yes, I do enjoy these questions on the test. Okay? So as an example, if you were given the question, let's see here, 12 divided by 2 4/5. Okay, notice 2 4/5 is very close to 3, right? I don't know why I wrote 14. 12 divided by 3 is 4. So the answer here is going to be pretty close to 4. But my question is not whether it's 4. My question is, should it be bigger than 4 or less than 4? Which one? And if you picture this as being written like a fraction, 12 divided by 2 4/5, and you compare that to 12 divided by 3, you'll notice the denominator over here is larger. And what happens when we have a larger denominator? One of these is bigger. Once you determine that, even though you don't know the actual value, you didn't compute the actual value, you can tell me which one of these values is actually larger. Okay, so 12 divided by 3, if you wanted to, you want to keep going. 12 divided by 4, well, 12 divided by 4 is 3. 12 divided by 3 is 4. So what I want you to see is as the denominator gets larger, the quotient gets smaller. And if it gets smaller, it means it must have been bigger to start with. So keep that in mind. If you increase the denominator size, you make the overall value smaller. If you make the denominator smaller, the overall value gets bigger. What a fantastic type of question. Yep, I like those. All right, other questions on here. If they had a faculty reduction, they lost 1/5 of its faculty. They lost 1/5. Okay. Again, if you lost 1/5, it doesn't matter how much you started with. If you lost 1/5, it would be something along these lines. I started with some amount. I take away 1/5 of that amount. Notice that if you did the distributive property up here with whatever number that is in the cloud, doesn't matter, you'd have cloud times 1 minus 1/5. And 1 minus 1/5 is 4/5. That is my hint to you along the way here, because you basically, instead of trying to do 2 different operations, you could just do one operation and it's a lot easier. If you lost 1/5, there must be 4/5 remaining. And that holds true down here too. In question 14, it says a company increases each year, increases their salary by 1/10 of the previous year. Okay, increases by 1/10. So whatever you started with, I'm going to increase it by 1/10. And if I use that distributive property, I get 1 plus 1/10, which means I end up with 11/10. So if I'm increasing by 1/10, I get 11/10. See, originally I would have had 10/10, but I got 1/10 more. Now I have 11/10. If I reduce it by 1/5, I have 4/5 left. And that is a really good idea because it makes things so much more convenient as you go forward. Let's see here. 29.5 yards of material to make doll outfits. Fantastic. Each outfit requires 3/4 yard of material. Hey, each outfit requires this much. How many outfits can be made? How much material will be left over? And when it says how many outfits can be made, there might even be a fraction of an outfit that was made. Maybe you couldn't make the whole last outfit. And so I want you to be able to answer a question like this. I do enjoy a question like this on the test as well, because this repeated subtraction model leads to the most mistakes, even though it's the most common one for people to draw. So she finished 3/4 of the book and has 82 pages left to read. Once again, if you finish 3/4 of the book, how much of the book is remaining? If 3/4 are done, you have 1/4 left. So 1/4 is 82 pages. Okay. If you wanted to, although you also could do this one, depending on the students that you deal with. The students may prefer to say, wait a minute, let's break that book up. Here's one book, and you've done 3/4, right? So 1/4 is left, and 1/4 is 82 pages. At which point in time, you could kind of see 82 pages is how much is in each one of these pieces right here. So you could determine how many pages have you read up to this point, and that would be a quick way to do it visually. Let's see, 16 I skipped. Then we're into exponents. So this is a great chance for you to practice your exponents. Write the following answers in simplest form with positive exponents. So if you have a negative exponent, remember you can rewrite that as the reciprocal. Very, very helpful. Question 19 is all about the same properties, but it's asking you to, which of the following are true? So use that box from the book that listed all the properties and then kind of apply it to here and say, which of these are actually true? Let's see here, 20. Now you're doing problem solving. And I will give you a hint. If you are doing some of these that have exponents, and I can see some that do have exponents, like even this first one, and it says 2 to the n. And I'll do a different problem. Let's say that it says 2 to the n is negative, I don't know, 27, let's say. I'll do 3 to the n. I'll do 3 to the n because it needs a 3 there. So 3 to the n is equal to negative 27. When you have this raised to a power, you know, based on the prime numbers that we've dealt with in chapter 4, that this thing over here had better be a bunch of 3s or something like that to some power. And I think I need a negative on that, but I'll just ignore the negative for now. Think of 27 and say, how can I rewrite that as 3s? And if you need to, break it down as 3 times 9, and then break it down again, go all the way down to primes so that you can rewrite it as 3 to the third, and then you can look and say, well, then my exponent had better be 3. Okay. Now, sometimes it may not be possible. I scribbled out the negative there because if I had a positive number and I was trying to get a negative out of it, that would be not possible, right? That's not possible. But other times, something may be possible. So keep that in mind as you go forward. 21 is solving inequalities. And again, inequalities, what you're looking for is, once again, I see 3 to the x and I see 81. Break 81 down. Break it down until you can make it into a bunch of 3s. Okay? They're trying to give you pieces that kind of connect to each other. Over here in part B, 4 to the x, and they give you the number 8. 4 is not prime, but I could break it into primes. So rewrite it as primes and rewrite 8 in primes. Might be a little bit quicker for you to see those. And lastly, determine which of these is greater. So you're looking at 3/4 and 4. So sometimes the exponents are the same and sometimes the exponents are not the same. I guess the one thing they want you to understand is when you multiply by something bigger than 1, the absolute value gets bigger. If you multiply by something smaller than 1, the absolute value gets smaller. So again, very important to think about those as you go. That, again, which one is bigger? So very similar to the one right above. Think about breaking things down into primes would be my hint. Big hint on that one, take the primes. That should do it for right now. Off you go.